Thanks for joining. Today, day number 10, we are going to discuss mostly the APIs, theory, and all those things. But day number 11, we have all the hands on. So, whatever we will study today, tomorrow we will see those things in action. We will perform the lab task. Although at CCNA level, they are not expecting that you know each and everything related to DNA programming, SDWAN, NSO, etc. Here, the main agenda for this course is that you know fair bit of programming, but you should understand all the concepts. Understanding the concept at CCNA DevNet level is required, and then Cisco has break their technology in enterprise automation, data center automation, ISP automation, like all the areas that they have automation topic there as well at CCNP level. And then finally we have one CCI level DevNet as well, right? So DevNet is we can think that one of the entry point that we have related to going towards the AI machine learning as well, because if someone knows programming skills, these formats, they can be used as a input to those big algorithms that will be used later on in AI or machine learning, etc. Now, what Cisco has done, since it's very difficult, complicated to learn machine learning and AI tools, it's not tools learning is easy. AI algorithm, how they are working. So Cisco has started to plug in their AI tools within Cisco Catalyst system. Cisco has rebranded their SD-WAN as a Cisco Catalyst SD-WAN. Cisco has rebranded their DNA to Cisco Catalyst DNA. And in these catalysts, so in Cisco Catalyst DNA, they have added the machine learning and AI related modules. Likewise, Cisco has their own cybersecurity product. There also they have integrated this, and Cisco has their own data center products such as Intersight and others. There also they have included the AI modules. AI modules, nothing but the algorithms that will go and check same type or different type of events, and with those events they can learn, and then they can give their feedback, even they can generate the RC, etc. Now, where this programming will come into the picture, if someone knows programming, then he knows that JSON format, this XML format, and all those things. Maybe tomorrow we need to feed those things manually to these AI engines. So those tools, they need some input, and we can provide these inputs to those tools so they can give better optimized output. So that is one of the use case that you can think that we should know the automation programming. We can reduce our operational task, the repetitive task, by doing some automation. Still some human intervention needed, because when we are dealing with iOS upgrade, or when we are dealing with machines, whenever you do upgrade, maybe some bug will hit and other things will come that my script will not understand. My script at the moment that we are studying, that limitation is this, that certain human task can be automated. So suppose if it is taking 2 hours, with a script it will take 5 minutes. But where we are applying this script, for example, some Nexus switches or other hardware, how they will react, either human task or these scripts, because we are doing the task. How we are doing the task, that mode we are changing. We are not going clicking GUI this or CLI running this command. All those things is feeded within the script and pushing to the hardware. Now after that, how this hardware will react? Maybe it is hitting some bug, maybe that particular configuration or image having some issue, that again someone has to fix, right? So still we need that human touch there. So that is the limitation of automation as well, because I don't know where I am applying this script, how it will react. Now that reaction can be taken within the AI engines, and they can check the patterns, how they are working. They are checking the patterns. So they will check the patterns like 10 times. If it happens, then what was the reaction and all. They can have some probability engine or probability stats. According to that, they can give the feedback. But it's still that AI also need to learn. They are learning and they are developing or evolving, right? But these scripts that we have, we can modify it, but it is not taking any feedback and giving the result. So it's very much like flat, not like complex algorithms that we have for just like AI and all. So you can understand the differentiation. But yeah, if we know programming, it will be helpful to reduce the overall operational task, troubleshooting task. The accuracy will be more because your script that you are running one time, that is 100% successful. So next time also it will be 100% successful, right? So those things are there, those benefits are there with a script. And then how this pattern will, pattern will be developed and it will be learn and evolve and all those things, that is there in machine learning and AI. Okay, so let's start the topic. We have, anyways, today I told you that only we have the theory. So here you can see that we have model driven programming. This is examples are Yang, RESTconf and NetConf. We know these are the protocols to configure the devices. These are the protocols to configure the devices in API method, like HTTP methods, which have post, put, get, delete, etc. Those methods. Yang is one other modeling language that has the structure. So it has the structure. Yang has the structure, and those structure can be used to do the automation. So let's start with Yang. Yang is a language that will model the configuration. You can see this is state. When I was doing my computer science graduation, at that time these states are coming into the picture, like a state changing, a state 1, a state 2, a state 3, a state 4. Even when we are configuring our devices, so when we are configuring something and then we are committing something, so configuring is some state that is not in action until unless you go and commit. At least the Juniper devices, we have to write one commit. When you are doing the commit, then it is saved and then it is operational, right? So you can configure is one state, you can commit is one state, like that. So different states are there for machines. So Yang also, it's very much like a state uh, based on a state of the networking devices. It's a modeling language, and it has a well-defined structure. So Yang has a well-defined structure. Cisco provides many standard custom Yang models. Well-defined structure means that let me show you an example. You'll understand it is actually easy to understand. So for example, I have one switch. I can go to switch a router, interface gig E00. I can go to the interface, then I can go and give this description. Say this is uplink. Then I can go and give IP address and then the some subnet mask, or maybe then I can go and give no shut, right? So this is the configuration that we are doing over a switch, over the interface. Now in this configuration, if you go and model it, so for all the interfaces, you have same type of a structure configuration. Maybe some switches, or let's remove this switch. For example, router. So all the routers, you have to go and give some description and IP address and no shut. Like if you are configuring that router, then obviously you have some configuration at the moment, only 3 lines, but you may have some other settings, blah, blah, all those things, QoS settings and access list and all those things. So many things, right? But what will be the model? Model is this, that you have your interface. So suppose we are creating model for interface. So that's the list interface. Now in that interface, so one container you are creating for interface, in that container you have key, say name of the interface, that is the string. So gigabit Ethernet 00, this is nothing but a string. Then description, that is also a string. This is uplink. Then IP address is not mentioned here, but IP address also we have format, IP address and subnet mask. So you can define IP address and you need some decimal or some number type of pattern to define the IP and subnet mask, right? Then no shut, shut or no shut. No shut may be true, shut is false. So enable, the state of the interface is boolean, shut or no shut, true or false. So this is like this. So this is the model, in this model, what exactly, so you can see the model example interface. This is a model defined by IETF, parameters, XML, NS, Yang language, IETF interface. So this is the model that is supported by iOS XE devices. We can use such type of pattern to do the automation for iOS XE devices. And there are some Cisco inbuilt modules as well, Cisco inbuilt data models as well that we can use and configure the devices. But this is the model, right? This is the model. When in this model, if you have to do some, if you have to fit these values, right? These values, you have to put these values. This is the model. This is the format, right? But in this format, if you want to feed something, you need to go and use some encoded method. Like, so the feed, the values that you will put, that will come via XML. So you have some XML file that you can import here, and then these things will be configured, right? So model and value, still you need data encoding to feed this model. So model wise is actually very easy to understand, and this is basically used in NSO environment. This Yang we are using in Cisco devices in NSO environment, and with NSO, it can orchestrate Cisco and non-Cisco devices both. This NSOs has, I think, those capability. We have actually example for Yang model. If I have, this is the way you will feed the data. Maybe they are not expecting in this exam to have the examples related to that, but I'm preparing for my CCI DevNet exam as well. So we have examples for Yang model to do automation to NSO devices, right? And maybe it will be not useful for you at this point of time in your infra, but if you want, I can give you some examples related to Yang, how it is working, how we can automate the networking devices. All right, let's move. RESTconf, I'll not spend much time on RESTconf because we know this is using RESTful API. It can go and we can go and feed the data as a JSON or XML. So it can understand both encoded data encoders like JSON and XML, or data formats JSON, XML. So you can see that we are using curl method, and this is the data encoding in terms of JSON. Want to configure interface, gigabit Ethernet description, and now you can see this model here. You can see this model, right? This Yang type of model. We are defining the interface. Then we have the interface. This is nothing but the container. In that container, we have name, value. Name, value is like key value, key value, key value. Very much like, this is very much like JSON format, right? Not exactly the JSON, but it's very much easy to understand. It is very much in terms of human readable format. This is JSON format. This is not the Yang format. It's very much like the Yang modeling that we have. But this example is for REST-conf API. Then netconf will also do the same thing, but it is understanding only XML encodings. So should be written. Netconf is a network management protocol that provides mechanism to install, manipulate, delete configuration. It uses XML encoded data and runs over SSH. What is the example that we are using related to netconf? We know that the best example for this is vmanage. Vmanage is using only netconf protocol to configure all the devices, even the controllers as well, like VS, CS, VS Smart, all the devices. Netconf is used via vmanage to configure the devices. Okay, so that's the live example we have behind the scene. Vmanage is using it. And then here also you have an example. NC Connect is one of the package for netconf. You need this to install in your Python as a package, like pip install NC client you need to install, and then connect the device, and you have the XML data. You should give the XML data. This data should be there, right? So you can see what we want to configure: gigabit Ethernet 2, description configure by netconf, enable true, done. So it will go and configure the interface, gigabit Ethernet interface 2. Don't worry, these examples are there. We can perform the lab task as well, but it's very a small example. What you will do with this, just configuring one interface. So you need full-fledged data. You need to develop full-fledged data that exactly what you want to configure over gigabit Ethernet 2, like, the description, the IP, the subnet, other configurations and all, then only it will be useful. Otherwise, why we will go and use such type of options? We can use Python modules to configure the devices. So that means that in your automation system, you have to go and build this. Someone has to go and build these XML files. So within the same package, within the same module, you have to go and build it. I can show you this built up and all those things. I have examples related to this. And if you remind me, so once we end the course, so you remind me that how to build this encoding, because this is not part of uh, like, normal automation training. This is something that I am using it for my exam preparation for my CCI DevNet, and I have big file, big list of configurations and all. I can show you that how these modules, some modules look like. Once you are developing a program, then that program having so many things, like, you have to develop XML or JSON formats as well, because you can develop the program, right? You can develop it, but you need some input, you need some values, right? So those values maybe come via the XML files anywhere in that folder, or JSON file anywhere in the folder, right? You have any question, please feel free to ask.
So in netconf, we don't have the option to use JSON, right?
Yeah,
It's only XML.
XML, yes, understanding XML.
The wireless controllers, they use that one, no? The, I think Yank or Netconf. When we add the wireless controllers and the DNA, they're asking for this protocol and the port 830. And you ask
Put
me
it,
actually.
yes, yeah. In DNA, we are using this. Yeah, in DNA also we are using, in SD-WAN also we are using. The netconf we have to enable. If we do not enable port number 830, then all the telemetry services will not get enabled in DNA. So that is mandatory that we should enable the netconf port 830. By any chance, if it is not there, then it is suggested by Cisco that you rediscover with these option. Like suppose it is already in DNA and those things are not enabled, then you rediscover the controllers with netconf port number 830. Okay, so let's move to next topic. This is purely lab, this topic. But today we'll discuss that program only. Next class we'll do the labs. One lab is saved. This lab is saved for our assignment. You can see 3.9b, manage space participants messages in WebEx. This is one of the lab that we will do later on in our assignment because this is a big lab. Actually, this is not expected. This is part of collaboration. Cisco is expecting that you should know this, that how modules are defined, functions are defined and all. But we will do this lab. We will see this in action. Apart from that, in this section, what is there? Construct a code, perform a specific operation based on the requirements below. So you have to actually have to create a code. They have mentioned that create a code, manage a space participant and this, obtain a list of networking devices for these. But they are telling anyone like either ACI, SD-WAN, NSO, DNA or anyone, get the list of devices, then get the list of client either by Meraki or Cisco DNA. Because if you get from here, you will get from here as well, because the APIs will look like same. They're very much same. So let's see this. 3.9a. Obtain a list of network. Okay, before going to this section, what will be your approach? How you will get it? Easy, right? Let me write like the methodology I'm asking. So what we are doing? We are defining the package, right? Package on the top, like import statements and all those things. And then we are defining some sort of URL, how you can log into the devices, like logging credentials, right? Then you need some API, and those API are embedded within the URL, right? Then what you want? You want some sort of response, and response you are saving as a JSON format, right? Then what you can do, once you have the response, then you can go and use the Python trick. Like you can go use for loop for ABC in response, and then you will use print anything XYZ. Done. So your programming format will be like this only, right? Let me show you this. You see key and this, and let me go with DNA first, then I'll come back to Meraki. I should write all these things here. Anyways, let me remove this first. 1, 2, 3, 4, 5. You can see defining the package. I haven't mentioned the function here, but yeah, that's okay. So you can see the packages and URLs, right? Then the URL is actually the API response. So you have one function where you have response. This is there in this only header. Anyways, you can see that you're defining one function to get the token, because in DNA programming, SD-WAN programming, you need token. I should add one more line related to token as well. So now we have the token, then we are defining some sort of header, because later on in the response we need the headers, right? Okay, so now here we will see that response, we are running the response, we are storing something within the response, right? Then devices, so this is the devices, and then you will see we are using this Python function. So for device in devices, print device. But I'm telling, this programming will be very much like these steps, all those programs. Find the package, credentials like credentials, username, password, tokens, etc. Then define the API. You should know the API. Once you have API and response, you're almost done. Then that API and response you can print in a table, Excel, PDF, whatever form, and then the result. So here your Python trick will come into the picture. Here your API skill will come into the picture. Here this is just the package calls, import statements and all. Right? You have any doubt in this? It's straightforward, right? No problem on that. These labs we'll do tomorrow. Okay, let's go back to the Meraki example. There also the key, the header, the response, then you have the networks, then you are using this in the for loop, and then you are printing it, devices one by one. Little bit change is there because how we are storing the result and printing the result is different in different environments. Now you can see ACI. ACI is completely different, but still you see that you need packages, URLs, APIs. First of all, you want to log in, so log in and get token, and then you are using some post method. You have your payload just to log in, and you have the token. Now once you have the token, then you can go and get the list of devices. This is the API to get the list of devices. API node, class, topology, pod 1, etc. And then this is the response. Then we are printing the list of devices. I have added all the example. Then you have Cisco SD-WAN. In Cisco SD-WAN, import the packages, URL login, device URL, then response. Then you have this devices, and then you are printing the devices one by one, right? Then I have added NSO as well. NSO. Then you need the response, right? You have the devices. From this response, you are filtering actually the device list, and then you are printing the devices, right? So you can see very similar. That's why I have added all the examples one by one. Either NSO, SD-WAN, ACI is little different. You need to understand ACI, APIs and all. But REST, DNA, Meraki, SD-WAN, those automations are very much same, right? Any questions so far?
Okay, can you put the Meraki script?
Meraki.
Okay, yeah. So sorry, because I didn't see it. So I was checking if you have a loop for every network. But yeah, I can see it now.
Yeah, and below we have loop. But anyway, this is just the example, like a samples for the example. When you do the actual coding, then you can change the format. Like instead of printing the devices like this, or only printing the device. You need some other attributes as well for the devices. So once you go and run this, so first of all, run this API in Postman. Use Postman and check that this API, what are the output we are getting. Either use Postman or you can use the API doc, Meraki API doc. With this particular API run, what are the attributes I'll get? What are the components we can get? And then in that for loop, we can go and get those results. And then we can print in Excel or we can print in the pretty tables, tabulate form. So that example I'll show you in next session when we'll go and print the DNA related or SD-WAN related networking devices. So what we'll do, we'll take the host name, the management IP, uh, other things as well, like other 4 or 5 things as well in that Excel sheet. So it will be like meaningful for us. Although in DNA, we don't need to run that script because DNA, we can go to the provision inventory and we can simply download that, right? So in DNA, it is not, but again, this programs are something that you're developing for different tasks that you can do from one single place. Like you have one place where you can go and run this program and get the result. Earlier, I told you that Cisco, why they are not developing a tool, and then I have done one research and then I found that Cisco has this tool actually. Cisco has their RAD kit, Cisco Remote Automation Development Kit. With this, it we can do the automation, and you can check this Cisco live recording. This is a recent one. This is not very old. So what this RAD kit can do, you can see that it has all those inbuilt packages and all, and then you can um, check many things. Switch over primary, this software development kit is there. Based on whatever we are studying, what they have done, that they have packaged everything within one tool, and with that tool, you can go and do the automation. You can have a look on this.
Is a free tool or is a licensed tool?
Um, Actually, I don't know much about this. I was doing research and come to this, but I don't think so. They will sell it for free.
Hmm.
Must be some cost will be there, and when Cisco is there, then obviously it will be expensive.
Nothing free, no?
Yeah,
Only
I
the
need to log in.
documentation is
I'll
free.
not log in it, but yeah, you can have a look on this. Means if you have any Cisco sales team, at least you can get the demo for your company, so they will tell that what are the capabilities and all. Good thing about this tool is this, that this is also evolving. This is not the final product. So version 1, 2, 3, 4, 5 will come, and slowly from this tool, engineers can automate the entire infra. Okay, maybe some company they acquired RadKit, maybe some other company that Cisco has acquired, and then they are rebranding it. So, but yeah, tool is there. I was thinking that why there is no tool from where we can go and automate the infra. This tool is there. They have, I think, 120 days free. Like this is for free for 120 days, and after that they will charge. So how much they will charge, I don't know. Maybe number of services or number of endpoints, or maybe one time cost. So that thing need to
Because
be checked.
all the tools to be gonna be expensive. We look the other way intentional is another tool, but it's very expensive. Intentional.
Yeah, other tools are there, like Glueware tool is there, NetBrain is there to do automation, but they are very expensive tools. They are very expensive, and better that if we are managing the
Potentially.
devices, if you are managing the devices via Cisco DNA, better you can automate via this, whatever we are learning here, like Python packages and all those. Like you have an automation server where you can develop your own packages and functions and program, and from there you can automate your tasks slowly. Slowly, you have your own software, right? So, but that is there that companies, for big companies, money is not a big thing. They can go and spend money like anything. That's why Cisco is giving 120 days free trial. If it is useful, then purchase it, otherwise leave it. Okay. All right. Now coming to this managing WebEx space, participant and message. Good thing about this is part of collaboration, but the format will be same. So let me show you this. On top is the heading, managing spaces, list of space. List of a space, you can see that you have packages, you have the tokens, URLs, right? Now you can see that again, like you are creating the list of devices. Likewise, you can go and get the list of a space. So this is the API, right? And this API, you can see we have the response for the API. So once we go and run this API, it will give you the rooms. Then we can go and print it. So if this is there, print a spaces for a space in a spaces, a space and title. So like that, we are printing the rooms, calling the API, printing the rooms. This is list the spaces, then create a space. Suppose you have to go and create a space in WebEx. So that will be what? That will be the post method, right? So you have the tokens and all. You need some payload. This will be your payload. So I have my URL, but this time we are using post, right? URL, header and data. What is this data? This is the payload. And here you have this. Once you run this, that means that will get created. Now, if you want to print it, then you can go and print. So a space, you can see a space equal to response.json. And then this space we are printing. Created a space title, and this is the space ID. Like that, a space will get created. You can see very much like DNA automation or Meraki automation, like that we are doing this methods. Then managing participant, list participants in a space. Now in that particular space, how many participants are there? So for that, we have different API. So membership we want to know, and this question is for query. Even when we are doing some Google search, when you are searching something, this means search. This question mark means search. So room ID is space ID. Room ID equal to space ID. So within this space ID, what are the members? This is the API. So if you go and run this, because this is the get method, we want that list. So use that get method, create that list, and then print it. Participant personal email or person email. It will go and print, right? Then add participants in a space. Suppose now you know the spaces. Now you can create the space. Now you know the members in the spaces. Then suppose if you have to go and add the participant in this space, then you will use this particular URL, because you need to add something. So you are using the post method, URL headers and JSON data. So this URL we are adding now. We need to give some input, right? So you can see this input. So this space ID, I want to add this email address. So this is the ID, this is the payload. This is space ID, we want to add this email ID. And finally, you can print the result, added participant whose email is this, and participant ID is this, added. Else failed to add. So we have this condition if else, add it or you are failed, right? Finally, manage messages in list messages in a space. So if you want to list the messages, you can go and list that. So for that you have this API. With this API, because you want to print that, so you need to get this get method. You can go and execute this API. Once you execute this API, whatever message is there, you can go and print that message. So print the message into the text. It will go and print all those messages in that space. Send a message to a space. Now you want to send a message, means you want to create the message in a space. So for that you need the post method. What is your message? So what is your room ID and your message, like hello webex, this is the payload. You are using this API, and then you are executing the API like this. Then if it is successful, we want to go and print the message, it will go and print the message, right? So now what is this? Opening webex and sending message, how easy this is. Right, so no one will go and use such type of program to do that. That's the thing, you have option, either you use via GUI method, or if you are use this automation. Initially to develop the program it will be pain, but now if I can go and convert this to a menu based program, I will run this program, it will ask me one, list a space. If I type number 2, then create a space. If I give option 3, list the participants in a space. Option 4, add the participants in this space. Option 5, list the messages in it, like that, so I can create this, I can use these APIs, these programs, and either I can create menu based function, or I can create, say, any type of web URL, like web page is there. In that I have option 1, 2, 3, 4, 5, 6, 7. Like I have 100 options related to managing the WebEx from one website, right? So power is there when we'll go and add different tasks to one program, within one program. That's the capability. Within one program, or with help of one program, we can automate SDWAN, DNA, WebEx, everything we can do from one place, and maybe one program or two program. That's the power we have. These scripts can be integrated together in one program. So I will go and create my web application. Someone will go and log into the web page. It will ask me, you want to do automate for DNA, for SD-WAN, for WebEx, for ACI, for NSO. Suppose my task is to create something in SD-WAN. I will click SD-WAN. Then when I go to SD-WAN, then it will ask me 200 things. This is related to SD-WAN. Suppose I want to see the certificates. So I'll go and click the certificate option. I just wanted to check the expiry date and all. So once I go to that certificate module, then this certificate valid till this, you want to renew, you can go and click renew, and it will renew via the program. So such type of flow if we can create with the program, then it will be very useful, right? Any question in this section? We will do these labs later on. This we will do, a space lab we'll do later on, the WebEx lab, but the other lab we are going to do tomorrow. In this last, we have this 3.9c, where it is expecting to get the list of client or host within the Meraki or DNA center, either Meraki or DNA. The format will be the same. I'll start with DNA, then I'll come back to Meraki. DNA, because I have done a lot of automation with DNA. So that's why I have all the library and function and packages. So you can see these packages and URL and get token same. Earlier we have seen this same thing. Then somehow I need one API that can give me the list of the client or host. So here you can see I have one API, client detail, right? Now I have this API and the parameter is also there, the timestamp. I have this API. With this API, I will go and use the method, like, REST conf method. So we are using this request, request, why we are using it? Get URL, header, parameters, nothing but the timestamp, verify. Now, this response is done. Like once you have the response, you are done. But this will give you raw output, like everything will be there. If you want to filter it, then you can go and use some sort of Python tricks. So if response code is 200, then clients equal to response. You can see we are filtering from here. We are filtering from here like this. And then we are using the for loop to print the client only. So from client into the clients, print the client. You see the structure format is easy, right? You develop this thing, get the token, and then you can print it. It's not a big deal. Now let's go back to Meraki.
Sorry,
Yeah,
Ranesh. That Python will give you the clients that are connected, or the one that are some at some point they connect to the network.
connected clients only. If you go to assurance, you will see the wired and wireless clients with their MAC addresses, with their details. And in that, you can see the name as well. Name like maybe Dell, maybe ABC user, maybe this user. So all those things it will come. I can show you that connected client. Let me log into DNA. Oh, I should have DNA. What was that? The URL for that DNA? The DNA. mm, mm, DNA RTP. I'm checking that sandbox where we have the DNA. We have some open sandbox, right? We can log in anytime. Anyone know that URL? Uh, 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 uh. Let me try. Let me try and let me try to fetch here. I'm not memorizing this. DNAC. Yeah, DCloud DNAC, something like this. Okay, let me go there. What client it will give you? Let me quickly show you that where you can find it. Come on, it is asking about IDs and all. One second, I'm trying to log into that. Okay. If I can get any DNA, I can. It's coming. This you can access this link. This is always on type of sandbox. Sometimes they are very slow. and better you can open this in the private windows and all. Otherwise they will not open. Now it is also asking the username and password. Refresh this page. I think today it will not open. Just one more minute. Okay, meanwhile it is opening. Let's go to Meraki. Let's quickly discuss this for 1 minute. Meanwhile, my DNA is loading slow today. It will open. I'll show you where you can see the client details. So you have the Meraki header URL. This is important. This is your API, clients related API. Then you can run it, print the client. Otherwise, it will be failed. Right, that's it. Output is okay. That is in the JSON format. So you need, this API is important. Understanding the APIs, that with what API, what it will do. That's why we have good amount of supported documents related to APIs. We have good amount of those supported document related to API. For example, if you are in Cisco DNA, you can go here to platform and you can see all those APIs, right? Let me show the client details. You can go to health. You can see this client. Once you come to this client, it will show you all the connected wired and wireless clients. Now you can see that Cisco has added this AI analytics. That's the module that I was telling you earlier, that in Cisco, now this is Cisco DNA Center. It is rebranded now. Now this is Cisco Catalyst Center or something like that. They have renamed it. It's very slow. But yeah, this is the client section. So whatever output you will get in the client section, you will print, it will get printed via the program that we have here. Not only that, but you can do lot many other things as well, like, connected switches with the client. You can see wired and wireless. You can see the example here, wired and wireless, MAC, IP, interconnected port. These details you will get from this. Okay, you have any other question, please feel free to ask. We are very much done with today's session. Tomorrow we have to perform the lab. So probably tomorrow I will show you this in the lab, right? The GUI
Okay.
as well and from API as well. You'll understand more about that. And then we will start this giant topic. This topic is very big, but let's focus on section 3. Section 3 is also very, very important. We should understand each and everything in section 3. Then we have big topic In section 4, you can see the list, huge. Okay, so that's the class for today. If you have any further question, please ask. Otherwise, we will stop. Thanks for joining. Today we have one lab. Actually, multiple labs we can perform related to DNA or Cisco SD-WAN, where we want to get the list of clients. And then there is one more, that is list of networking devices. So list of client and networking device list we want to print. Now, although I have these scripts already I shared, but I just wanted to show you that with help of GitHub libraries, how you can go and build it from your own. So let me clean this. You can go to GitHub. Okay, you can go and create your username, password, and all, and then you can log in, and then Cisco DevNet. You can see Cisco DevNet having the DNAC script. You can search DNAC template, and you can see top 5 and patch and all and all. There is one guy who's writing very good professional scripts. Where he is? Let me search. You can follow his script. IP to phone, IP to phone. Okay, let me go like this. Cisco. This community you can. Let's go to Cisco DevNet, and here this is very nice repository. NetProg basics. Then here we can search DNA. Otherwise, you will see so many different programs are there. SD-WAN DevOps. So in this, I can go and search DNAC. You can see DNAC, DNAC, DNAC. Let me go. So this is one. NetProg basic. You can refer this. They have given some username for DNA and password. Let me open this. This is one nice place where you can learn automation, and that is from basic. And all the documents are there. Supported documents are there. Programming fundamentals, APIs, controllers, like that is good link. You can have a look on that. Okay, assurance related. There you have some basic codes that we can refer. And where is that guy? He's writing very, very good programs. Okay. DNAC compliance. I was using the DNAC compliance. Let me go and search DNAC compliance. Yes, this. So let's go to his profile. You can go click and go to his profile. Yeah. Gabriel Chapo Denu. His programs are actually very good and organized and structured. So he has lot many programs for DNA as well, and other platforms as well. We can see DNAC webhook receivers, fabric operations for SDA, and I want to see all his programs. So like that. Okay. This panel is also got changed. Okay. Go to repository. 59 repository it has. Catalyst Center. DNS Center day and that is template related. Catalyst Center platform. Let me quickly go to this. I haven't seen this earlier. YouTube. Some of these repository that we are seeing, they are presenting to Cisco Live. You can open any of them and you can have a look on them. SDK. I will open this because we have done this SDK software development kit. This is one of the nice program they have. It is there or not, I don't know. Yeah. Maybe some Cisco Live they have presented this. Config monitoring, create instance, DNAC APIs, intro to netconf, restconf, DNS entropy. All these. Don't worry, I'll open these things. I will execute the programs today. DNAC. These are very nice programs presented in Cisco Live. I checked all these programs. When you have time, you can also have a look. For example, this 3841, you may get document as well. TNAC APIs, save baselines, configurations. You can read this thoroughly. You can go through it, what exactly they want to publish. Okay, no problem. So since we are in the CCNA session, you can go and run a small basic programs. We can use we can take help of these programs, what exactly they want to do, and we can we can build our programs and execute it, no problem. So for example, I am here in this Cisco DevNet, DNAC APIs with Python sample codes. So I can go to this basic lab. In basic lab, what they have added: post token, get host, networking devices, network device ID, and get network device ID config, etc. So this we are going to execute today. Now what you can do, you can go to this place, you can copy this. Let me open my command prompt. I'm here. Then you can do git clone. You can copy their repository in your local system. So now it is there, and the name will be DNAC API. So this is the repository I copy. You can see the basic labs. I want to perform the basic labs. Let me put this. Okay, basic labs. You can see now I can go to basic labs. In that basic labs, you can see that we have dnac.py, dnac config, means some config file. So suppose if I go to post token, so if I go to lab 1, okay, lab 1. Now this format, it may be a little bit difficult to read. So I can do one thing. I can copy this to our Visio. Or what we can do, okay, I can give the folder location. So where it is, let me show you this. Open folder. You can click open folder and give the path. Okay, I'll do it because some unwanted folders are there. I don't want to highlight that. Let me go there. Okay, it is not there. One sec. So I will record this. So when you will watch it, you will not, suppose if something is missing, you can see that. So you can go to this file, you can see open folder, and then you can go to C drive. So this computer, C drive, users, this, and then you can see this, right? I can go to this folder. Then we have basic labs, select folder. So now you can see that we have all these programs that I can show you. Get host. So what is that? Release not okay. Lab 1, then 1 2, then 2 1, and then 2 2. Okay. So lab DNAC. Okay, DNAC config. So now you will see that we have the DNAC DNA config file, right? Where we have the sandbox, port number, username, password. So this is our config file. Then we have dnac.py. The script provides a function to get DNAC authentication token, and function make DNAC REST API request, all modules, blah, blah, blah. You can put some comments that who is the owner, writer, copyright, all those things. Then import packages, these things we know. Import DNAC config. That means it will go and import these things, right? That's username. So from DNAC config, DNAC IP, version, all these things it will go and import, right? Then you will see here that we have the URL for token, header. Then we have the request. But anyways, you don't need to go that deep on this. This is just to provide the token. Let's go to this program to get the token. So you have the packages, negating the warnings. You have the username and password. Again, now we are not, so this is independent program. These two are connected. This is independent program because you can see we are defining username, password, everything here. So later on, you can remove this and you can import and you can use such type of functions. So that's okay, no problem. Now we are here and we want token. So for token, we will go and use the token based API. We need the obviously the headers. Then while executing the token, we are using the post method, and then you can go and print it, right? So let's do one thing. Let's go and try to execute this program. So we are in the correct folder where we have the program. I can go and run this lab 1 post token. You can see. So this is the raw response post token pretty table. It is using some pretty function. So you can see that pretty. Okay. JSON dumps and putting some indent, but anyways, no difference in these outputs either. You need token, right? So this way you can go and print the token. Why? Because these tokens are important for next stage. So if you go to next stage, get all hosts connected to DNA. Now here you will see that from DNAC, see, so this program, this 1.2, it's connected with this. From DNAC importing everything. You can see from DNAC import as asterisk. That means it will go and import everything. And this program is connected with this program. So this program this is the body, what it will do. Let's try to understand. So try API. Now it's only you are seeing this host, API equal to host. So this is like little bit complicated. You have to go and understand that before this host, what are the other things we have in the URL. So that means you have to go and understand this program. So if you go here, you will see that you have to understand the structure of URL, the API, because simply what it is doing, that it will get the API host. This will be the last thing in the API. Last thing means slash something. What I'm telling, that when you have some API, see, it will start from API. API system version plus auth and then this token, like auth and token. So this is actual API. Now, if I want to see this, okay, so let's go and open the sandbox. Let me show you the API first, and then we'll go and work on that. But this is one of the style. Our style, we also have programs related to DNA and all, and which is very simple, simplified, that I have shared with you. This is bit of complicated, but I have recorded this thing in your own time. You can go and have a look. We should understand these formats as well. How things are structured in this. Should know this. Okay. But we have better example than this. I'll do one thing. Anyways, I'll go and open this DNA. I'll open that which exact API we are working with. But let me open my script as well, because that is easy. Again, you have to understand this. It's up to you. If you find this is easy, you can use this. If you find our example is easy, you can use this. Let me have some space here so I can open my TNA program as well that I have shared with you. Okay. CCNA DevNet. Anyways, this is not part of anything related to CCNA that we are doing. It's a little bit advanced. Where is my DNA program? DNA device list. I'm also using the sandbox and all. In my example, you can see the URL clearly, right? And then it is giving the response. So let me check that first. CD, where we have, okay, I need to go to C drive and the document, CD, documents, and CCNA DevNet and section 2, and then, for example, author.exe 3.9a, and that section 3 for 3.9 DNAT device list. Okay. I have warnings and all in that program, but anyways, you can see this is working. If I want to remove these warnings, what I need to do, I need to use this. Let me do this thing. Copy. So if I run this program now, it will not give you any warning because we are using that, negating that warning. This output that you're seeing, this is just a dump, right? JSON dump. But what we can do, we can go and filter some of the important key, and then we can print it as a key value pair. One sec. Yeah, I'm doing something here. You are able to understand all these things, right? This is just for your study purpose. Anyways, you will get the codes and all those things. Now it's up to you that how you want to work on that, right? You're able to understand this? Just let me know. This is very basic program where we have the tokens. We're generating the token and just focus on these APIs. They are the key. Program and different type of styles, you will get it, right? But these APIs are important. Now from this network device, this is the list of network device. If I go to DNA and if I go and execute this API in DNA itself, you will get such type of list in better format. This is just the JSON dump, right? But in this, if you have to filter something, let me go to this. My bad. Okay, so what is this? 3.9, 3.9 DNAC filter or DNAC tablet. Okay, so what I am doing here that I just wanted to filter some of the keywords like host name, management IP, serial number, platform ID, software, role, etc. I don't want to print the entire dump here. You can see it's a dump file, but I want to print these files in only these headers, and I want to print in the pretty table. Let me show you the output and then we'll discuss about this. So now if I go here and DNAC, what is that DNAC? Oh, 3.9, name is 3.3.9 DNAC. Tablet, right? Let's see. See, now we have output like this. When we are running the dump, this is the dump, right? But from this, we want few things to see. So you can see the output. So now from this, I filter the host name. So you can go and see the host name from there, management IP. You can see the management IP somewhere. The platform ID, you will see the platform ID somewhere, which is C9KP, etc. Right? And then you can print like this. This is one of the pretty tables. Right? Any okay. And now how it is? It's easy actually. Here you will see that we are adding tabulate, this one function that will print in table format. Rest all those things are almost same. We are creating one table list here because we want to print this on top. The platform ID, the software version, the role, software version, etc. Then we have defining the headers. These are the actual keywords. But these actual keywords we want like this because this is better format than this, like role in capital ROLE. and then we have table, and then we are running, you can see we are running this API. This is my API, and then we are printing in print table. So tomorrow if we have to add one more thing here, simply what you will do, let me show you this. So we can do one thing, add one more key here. Let's go and add one more thing here, type, right, is this. So I can go here and use, let's see, device.get, you have to give type. If it will not get the type, it will print NA, not applicable. And then I can go here, highlight in caps, so we'll understand that this is our. So one more, type, right? Let's go and run this program. So role, what is the problem here? Oh, comma. Let's run this. Taking too much time. Why? Has some issue with role. Let's see. Connection error problem. Yeah, it has some unreachability issue. I will go and disconnect my VPN. You can see. You can see the output, right? What we have done. So you have the format. You can use this format and it will go and print the output for you. So we are building the code here, right? I'll go and add one more code here. Okay, 3.9 DNAC Excel. I just wanted to print this output in Excel format, right? So for that, we are using one other, you can see Python package pandas. It is there to handle the Excel formats and manipulation for that. So pandas SPD. Now the output we have. See the output we have. Now you can see that we want the key part in that output, like host name, the management IP, the serial number, etc., etc. But this, right, this information we want to print as an Excel format. So we'll take the device data, right? Device data will take. We are using the appendation. We'll append it, and then we'll put in the pandas, and then it will go and print the pandas network devices Excel file, and we can see the output, right? So let's try to run this. Where is that? Dank. Sorry, the name is incorrect. DNAC Excel something is there. Oh, without DNAC Excel. So we have some error. Oh, that error is due to my environment. My Python error is there. Actually, I'm running some AI related code in my system. So I'm getting this NumPy installation. NumPy install having some compatibility issue with the system and all. Let me try to upgrade that. You don't need to do in your system. Okay, let me try and one more time. Please, yeah, some NumPy error I'm getting. And I can't do anything seems. Let me try this. Install some packages there that is mostly used for AI related programs. Oops. Pip install NumPy. It's there already. Now what I can do, original error, some DLL, this Python related DLL error I have. Let me try some other things here. I need to reinstall my Python since then only it will work. Anyways, no problem. Let me check one more time. Yeah, so far you can see the script. These scripts are like, work. The key area here is this, the API, what exact API you're looking for. And then rest of the things that you have, like, this is the list, and then running the for loop and identifying the key areas you want to print. You can print it, even you will see so many online help, a different type of online help you can get, and you will reach a point where exactly what you want to get, you will get it, right? It's taking some time. Just taking some time to upgrade. Meanwhile, let me go to the DNA sandbox. Login. Just to show you, the API runs from there as well. Platforms. So if you are looking for network devices, you can search. And get device list. I can try. Take some time to load. Run. You can see the API on top, network devices. And the key values here. Yes. So there is one question that while running the script, someone can see our username and password, right? So we can encode that. I will show you that how we are doing that. Encrypting the user credentials. Okay, so it is throwing some error here, but anyways, you can see the limit of 500. Some error it is showing, it's not showing the exact output. But this is the place where you can go and search for the APIs, right? You can post your questions, no problem. I'll answer one by one. This is the place you can go and play around with, and you can come back to me and you can ask a query. You have this URL, username, password. You can have a look on this. Let me go back here. Seems the installation is done. Let me try to run one more time. Yeah, it has some Python error. I will correct it, but this is working program we have. Let me go and try to execute one more program, and then I will answer your question. This, we have the token and we want client health, right? So this is a DNA that will give you all client information. From that client health information, you can go and filter the client, right? Let me save this first. 3.9 DNAC client. Oops. 3.9 DNAC client. Now, when you are getting such type of error, no problem. The script in this location, we may not have any client connected or something. So that's why we have such type of errors. Don't worry about that. Okay. One way to encrypt your password is this, but I will show you the other way as well. That no need to go like this. Encrypt your password and then use. This is the little bit advanced way to encrypt it. We are using base code 64, etc. I will show you in upcoming examples. Actually, section number 4 that we have that is related to security. So in that, I will show you some script where you will not see these credentials on top. We have multiple ways. Either hide this in the same script, or you can call this from some other function, other program, which is not displayed here. So two ways we can hide it within the script, right? Either you can encrypt it here itself. We have base code 64, etc. We'll check that. Or you can call from some other place. Like we have earlier program, we are calling it from some other script. So these things we can do for hiding these username password. Okay. Any question you have? You have plenty tasks today. I have shown you multiple things. You can go to GitHub, you can download your repository, play around with this, or you can use our script that is already there in the shared drive, and you can play around with this. You have the DNA. open sandboxes, or you can go to Cisco DevNet portals and you can reserve the slot and you can practice it. If you have any question, please feel free to ask. Okay, let me pause the recording. Today seems everyone is silent.
No practice with the production.
Thanks for joining. Day number 12. We are going to start a topic that is related to, you can see, application deployment and security. Now today, the topic is going to be mostly theoretical. I'm going to cover all those parts which is very much theoretical. You can see the list, the agenda here. Describe the benefits of edge computing, identify different application deployment models like private, public cloud, hybrid cloud, identify the attributes of application deployment types like virtual machine, bare metal, containers. Only 1, 2, 3 I will cover today. Then we have to understand about CI/CD structure and Docker structure and firewall and some security threats, etc. So you can see that the list of topic we have from 4.1 up to 4.12. Actually, this is very wide. This area that you can see, it's wide because not only you have to understand the cloud infra or the private and public data center, you have to understand the script deployment models like CI/CD, and you have to understand about the Dockers, Docker files, Docker utilization, and then security parameters, right? So these things you have to understand. Let's start with 4.1, 4.2, 4.3, etc. Benefits of edge computing. What is the benefit of edge computing? I will go and explain you that, but from your understanding, can you tell me the edge computing benefits? What is edge computing? Yeah, can you tell me that people are working on this concept? What exactly is this theoretically? We can understand. Can you tell me that edge computing benefits? What is this edge computing benefit, and have you heard any model related to edge computing?
It's about data storage, maybe? Or no?
Storage, okay. Any other attempt? Um, okay, no problem. I'll answer you that. You know, a very interesting thing about our networking design is this, that we want to develop applications those are very close to users. That will be the actually goal of the networking design engineers, that applications should be available everywhere. Now, if application is, for example, available everywhere, that means that you will be very close, the not the users, actually the users, they will be very close to the application servers, right? So for example, if I have company and I have 10 branches, and these branches, they are at different geographical locations, different locations, right? Now, if I have all my applications at one place, suppose data center is in one place, and all these 12 locations at different 12 geographical locations, that means to use that application, everyone has to come to the central location, and that is my data center, and then they can access the services, right? So this model is not that great, because in that way someone has to go, means all the locations has to rely on one location, and then obviously someone has to route reach to that location and access the services. Then there come the concept of edge computing. Edge computing is something. Compute means you know that compute infra. You know that, for example, Azure or AWS or these cloud, what they are providing. Basically, they are providing the power of compute. That means you can go to any of these cloud locations and install any of the services because they have different type of service offering. And these service offerings, they are in different type of availability zones. Like they may be near to any of the users. Suppose someone is in Europe, so they will provide services near to Europe. Someone is in, suppose, India, then they will provide their servers there in Mumbai and other locations in India. Someone is in US, so they will not provide the resources to use the India compute resources. They will provide the compute resources in US, right? So because this cloud, they are available everywhere, they have their availability zones everywhere. So the service offering is easy. Likewise, what we want to do in this edge computing, we want to offer the services near to the users. Now, if we do that, what are the benefits we have? Benefit is this, that the resources will be easily available. It will be easy to put the security rules because I have to go and manage one area, not the entire area or entire tenants and user. What you can see that. Okay, I'll come to that point. But overall, this is the design in Cisco SD-WAN. This is SASE, SASE. In ACI also, we are using some remote leaf option or virtual remote leaf option, etc., etc. Everywhere in all the solution, we have this edge computing option. Now, if we use this edge computing, I thought you got this point, right? Near to the users, we want to deploy the services. So now if we use these services, the edge computing concept, it will reduce the latency because it's near, it will optimize the bandwidth, it will enhance the physical security, improve the reliability, resiliency, scalability, local data processing, user experience, cost saving, enabling the cost saving, I'll come to that, enabling emerging technology, contextual awareness, and automation operations. See, all these 10 benefits that I have mentioned here, and some points are there. But key is this, that you are using some sort of distributed model. So now here we can argue that centralized model versus distributed model. So this edge computing is very much distributed model. Services are distributed across the different availability zone, across different areas. And if we do so, drastically, we can reduce these things, right? And enhance the performance and all those things. Then I have added these points here. Anyways, if you are near to the source, then you need only one hop or two hop to reach there. So bandwidth will get optimized. If we are near to the resources, then security will be easy to implement. You can see processing data at the edge can improve the privacy and security by keeping sensitive local data rather than transmitting across potential insecure network to centralized servers. This especially benefits for application in healthcare, finance, and all those things. We know that suppose if some government data is there, and those government data are important, like so they don't want, so one country don't want to send their sensitive information to a store in other country, right? They want their local servers. They want to store their data locally. So obviously that will go and enhance the privacy and security. Like that, we have all these enhancement because the data that is locally available, so you can work on the optimization for that. Any doubt understanding this concept of edge computing? And in summary, you can see clearly, you see, edge computing offers numerous benefits by bringing computation closer to the data source, enhancing performance, security, user experience while reducing the cost and supporting the growth of new technologies and applications. Right?
Okay.
All right. So let's move to the next topic that will be, you can see that addition in edge computing. So now we know one fact that in our design model, we want to design a network that is widely available. I want to design a network that is available across different geographical locations, and in that way we can improve, enhance the performance of the applications, user experience, and all security features and all. Now, if we have to achieve certain tasks, so now if I have 12 different branches, right, and I have one business and which is growing, and now I have 12 branches, and I have some sort of physical branches where these 12 branches, either they are my branches or head office or main office or data center, etc. But now I want to open, because my business is growing, so in new geographical location I have to go and open one branch, right? Now, to open a branch, you need physical resources, servers, firewalls, networking devices, storage devices, compute devices, all that is stack, right? But suppose you don't have that much time, you are in hurry that you have to open your business, run your services securely. That's the one thing. Second thing, that you don't know that in that location the same business will grow or not. So if you go and do investment, for example, leasing the area, leasing the building, and then deploying the devices, hiring the engineers there, and all those things, you need resources, right? You need resources in that particular location, and it will be difficult at a time for business to go and grow in new location, right? Rather than, the easier approach is this, that you can contact any cloud provider and you can ask that, see, these are my list of applications at the moment my business is growing, and these are my applications. Could you please support these applications? And I want to host my application in that particular zone where you are providing the services, right? So that's the evolution of cloud we have. Cloud is nothing but someone else data center. Cloud is nothing but data center. They are where it's up to us that what type of service we want. We want full cloud services. We want to host our applications. We want, the different type of cloud flavors are there, like platform as a service, infra as a service, etc., etc. We'll see that, right? So that is one of the emerging uh, trend we have related to cloud, that you don't have resources in that particular location and you want to support your edge computing. You want to support your local network, right, in that particular area, because if you have local network in that particular area, you will enhance the security, performance, bandwidth, cost saving. All those 11 benefits are there, right? So that is related to public cloud, someone else data center, and private cloud is your data center, and hybrid cloud is mixed of data centers and mix of different type of clouds. Generally, we see that all the network, they are hybrid. They are hybrid data center, hybrid cloud. And then the edge is also there. Edge is something that some local resources that you have. You know, one of the nice example for this edge will be, obviously I told you SASE, this Cisco SD-WAN SaaS solution, or data center also we have edge computing options in data center. Let's go into this. Let's try to understand this. Private cloud, that is your own data center, and that's why you can see this marker here. That's the cost. Cost will be the higher, but it's actually very interesting. This is very interesting fact that what will be the timeline of your business? Your timeline of your business means that you are going to run this business, for example, for 10 years or 20 years or 50 years. According to that choice of private cloud versus public cloud, the private cloud will win. That means that initially, you can see this is very interesting fact. Initially, higher initial capital expenditure, but potential more cost effective for large scale operations and the operation that can go for 10 years or 15 or 20 years. So that means that suppose if your business is growing and you have to host the applications, right? The applications you have to host at the because the business is growing and you have high demand and you don't have your own private cloud, so you are going to public cloud and you are acquiring those services, you are taking those services from public cloud, no problem. But that public cloud benefit is there only in short term. If you have long term business like 5 years, 6 years, 7 years, 10 years, then you will see hosting those applications within your cloud, within your data center will be less expensive than the public cloud. And that's the reason you will see so many people that they move to public cloud, they are moving back to private cloud. They are deploying their own data centers at the locations and all, so they can save the cost, because you don't know that how they will charge. And sometimes we don't know that how we can go and use the services, and while we are not using those services, shut down the resources that is hosted in cloud. So unnecessarily the bill is coming. So bill optimization in the cloud services is one of the, can say that one of the headache we have, but in longer run that will cost more. This is a very interesting fact. Now for maintenance, you need internal staff and all. Scalability, you have limited internet resources to scale. So if you go and check the private cloud versus public cloud, there are pros and cons. Private cloud is something that if you want to grow, certain growth is not there. Certain growth is not there, but you can plan and grow. Cloud, they can provide you on-demand services because they have very big infra. They have big hardware infrastructure. Within that infra hardware structure, as per our requirement, anytime they can scale. Right, so public cloud owner are these cloud provider, location anywhere, security, shared responsibility. You can see the security parameter, highly secure because that is your network, that is highly secure. Here you have shared responsibility, customization is not that great. You are depending upon the cloud service providers. Performance, it depends. Sometimes it is good, sometimes not up to mark. And the performance for your data center, you have the predictable performance and dedicated resource. Your resources, you can play around with this, you can optimize this, and this is cloud resources. If something example is like this, that if you have to go somewhere, you have two options. Either you can purchase your car and go there, or you can use Uber or any transport services and you can go there. But for example, if you have to go every day for 10 years, then taking a car on rent every day, that may be more expensive than purchase your own car and go for next 10 years. And if you go and check the cost, purchasing a car, their maintenance, maybe driver fees and all those things, obviously it will be initial expense, but maybe in longer run you can save some money, right? Anyways, that is your asset as well. So not only going to one destination, you can go anywhere. That means that customization is there, but when we are reaching to this public cloud owners, we are fixing with services, say these services I need resources, we are defining the services to them. Here you can develop, grow your in-house applications anywhere. And because you know that you have your own resources and you can play around with this and they can work. Highly customized to meet the specific organization need. Yeah, you can go to one destination or you can go to multi-destination. It's up to you because your data center. Cost. Pay as go on pricing model, reducing the capital expenditure. Yeah, it will reduce the capital expense, but in longer run, this will be the costlier thing. Then hybrid cloud. Hybrid cloud is what? Hybrid cloud is nothing but the mix of private and public cloud. And this is some model that we should follow. We should not follow a strict public and a strict private. Whatever the best of both world, like private cloud also you have and you have public cloud also. So private cloud, why you are using, so you have your own secure applications, your own databases and all, everything you can use within your private cloud. And if you have new applications, if you are detecting that something new will come, those things you can go and host in the public cloud, right? Later on, those public cloud applications you can grow in-house, and then you can, you know, start reducing your load over the public infrastructure. That should be the goal for the enterprise enterprise network, that you have both the options, private and public. Your sensitive information, sensitive applications are hosted in the private cloud, and pay as go model means if you want to grow, all of a sudden if you have requirement you can grow. If you have public cloud connectivity, so you can connect with public cloud as well, and you can grow their application in public cloud. Parallelly, one replica you are creating in your physical infra as well, and later on you can reduce the load over the cloud, shift your network in your private data center if that business run is more. If it is for 6 days or 6 months or 6 year, 6 months or 1 year or 2 year, up to 2 3 years, it's okay. But again, you can create a chart. So this application, if I host in my data center, how much will be the cost? And if this application I'm hosting in public cloud, what will be the cost? And after 5 year, what will be the cost? After 10 year, what will be the cost? You'll come to know that which is beneficial. Edge computing, as already we discussed about this, this is near to the uh, users or customers, and it will go and enhance the security. It is customizable. It will meet all the compliances on all. So here you can see the chart. I have created a chart here. That chart, private cloud versus public cloud versus hybrid cloud versus edge computing, and these are the terms I am matching. Security, private cloud high, public cloud shared, hybrid cloud high, edge computing high, because anyway this is local. Whenever we have local resources, that security, performance, those things will be high. So you can see performance high, predictable, because you know that what is your data center performance. Variable, depends upon the resources. Predictable and all those things. Maintenance, scalability, accessibility, latency, bandwidth, reliability, and all. And these are again just the theoretical points. If you have any doubt in this, please feel free to ask. Anyone has any question?
No, sir. No questions.
All right.
The only thing, Rakesh, you say this time most of the companies are going in hybrid way, or
Hybrid.
because a lot of people say, oh, let's go to the cloud, but
Hybrid, yeah.
large
Hybrid,
companies are keeping hybrid or what?
hybrid. We are in hybrid model, but if your business duration is longer, then you can have your own data center. And these clouds depend. These depends upon the nature of business as well. So, for example, one company. Let's take one example for one company, Uber. Uber, they are providing their transport services across all the countries, like India, US, UK, everywhere they have their services. Now for them, how they are running their business? Uber business model is this, that they have mobile application. You can install their application in mobile, and then you can book the cab, and in that now they have so many different services, like rent the car, like this facility, bike is there and auto is there and four wheelers are there, and in four wheeler also categories are there, like normal, excel, premium, all those things. So they are, that means they have different servers for different services, compiling everything and putting in the front end, that is the user application in mobile, right? So they are running their businesses everywhere. Do they need this physical data center? Actually no, they don't need, because they are not some finance companies like any bank, like for example Fidelity Services, or for example, there are so many banks. They are here, they are across all the locations, like in India, US, UK, everywhere they are. Like American banks, and so many banks are there. They are everywhere actually. So these banks' business, their data is very sensitive with compared to these food companies, like in India we have some Zomato, other places we have Uber Eats. Uber has their transport companies and all, right? So it depends that if you really need, if your information is sensitive, like banking, government data, financial, railway data and all, so the data center for these organizations will be suited for private cloud. But if you have floating business like Uber Eats and Uber Transport and other floating businesses, where your most of your business, they are running via mobile application. So in that case, you don't need, you can run 100% of your business over the cloud, because anytime you can scale. For example, all of sudden, uh, for 10 million people, they have installed Uber in their mobile. So all of a sudden the requirement will increase. How they will fulfill the requirement? So they have to use these cloud resources. Anytime 1 million people will uninstall that application, means they are not using, they are going to some other, they are shifting to other transport company, right? So that's the thing, like prediction of business is also important while we are using these cloud resources. But cloud is not there for all the government organizations. Government organization using it, no doubt about that. They are using it, but they are using it as a backup. Like if they have all of a sudden, if they have high demand, then how they will fulfill? Because the problem with this private cloud is this, that they have fixed compute. You have only, for example, 50 servers in data centers, and then you want to increase your servers, then you have to order it, it will come, you will rack and stack, and then you will connect with network and all those things. It will take time, right? Minimum it will take 2 months or 3 months. But in cloud, like 2 minutes, you can spin up and it will work, right? So that's the thing here. uh, these requirements are actually as per the business. Why they want to move over the cloud? Because they have business requirement, right? If everything is happening in private cloud, why I will go to the cloud? No need, right? And if something you are unable to host in the private, then you can go to the public cloud. For example, nowadays we have this AI, evolution of this AI. Everyone is building AI tools and all. So do they have resources to host the AI application in their server? No, right? And you have pressure. Business has pressure that they have to run these or develop these automations and AI machine learning applications. So what they will do, since cloud they are offering nice AI features and tools and all, they can go and use cloud resources to develop their AI features, tool set and all, right? It depends. It purely depends upon the choice, purely depend upon business. All right, let's move to the next topic, the last topic for today's session. That will be a little bit interesting than these clouds and other. That is identify the deployment types. Now you will see that we have three different type of deployment model and all three are in use. Virtual machines, bare metal, containers. You need bare metals as well in few applications. You need containers as well. You need virtual machines as well. Now, if I tell you that goal of these uh, compute, because virtual machine also you can install some servers, bare metals also you can install some server, containers you can't install servers, right? That's interesting. The point here is this: what is the ask? What's the final goal? What exactly I am looking for? I am looking for businesses, actually they are looking for applications, right? They don't care. Simply they want to develop their applications, and then they, why they want to develop their applications? Because applications are something that is their services. They want to generate the revenue. Business model is this, that they want to generate the revenue, so they want new services. New services need new applications, right? Now these applications, for these applications what we need, these application can be run anywhere. So these applications can be hosted. So you can go and host this application over where? Over any operating system, right? So I can go and maybe I have Windows or Linux or anything. I need OS to run this application, right? Now we know that the bare metals, you have only one operating system, and in one operating system you can go and develop one type of applications, right? So in operating system you can go and install Python 3.10, right? And then that Python 3.10 you can go and develop applications related to Python 3.10 and other versions of different packages, right? Because one operating system, what how it can scale, right? And that operating system, for example, I have that operating system related to Windows, so I can develop the application only related to Windows. That's very interesting, you know, in application world, that is very interesting, that when the developers, the development team, they are building their application, right? Building their application, they have to test this application across different operating systems like Windows, Linux, Mac OS. And not only that, but they are testing these applications related to different version of Windows, like Windows 8, 9, 10, you know, different flavors of operating system related to Linux. You know that Linux, they have different type of operating systems. Then not only that, then they are thinking, oh, my user can use this application over mobile phone, over web browsing in any laptop, Windows, Linux, etc. So on those mobile, again they are checking their application. So the same application they are developing for mobile as well. And in mobile also, you know that you have Android, iPhone, and Nothing phone, and Google phone, and these, like there are also different operating systems are there. So then they have to go and check these applications on different operating system, different mobile operating system, etc, etc, etc. The task is actually very difficult, because maybe one system will support, other system will not support. So that means they have to develop the application for all different flavors of operating system. That is possible in bare metal? Answer is no. Then what we need? Then we need these virtual machines. These virtual machines, what they will do, that the same concept that we have, the same concept of application, but you have different OS for different application, and below you have some hypervisor or orchestration system where hypervisor. So I have one operating system. On top of that operating system, I can go and run a different instance of operating system like Windows based operating system, Linux based operating system, Mac OS, etc. And then I can go and develop different flavors of applications, say application 1, application 2, application, for example, N, right? Different type of applications we can develop. So now you can see that resource utilization in this particular use case is better. Rather than you have one hardware and you are installing one operating system and running one application, sometimes this is also useful because your application is that critical that you want to run only one application in one OS. So you need this bare metal as well. But you can see the evolution of this VMware technology. Not only VMware, but there are different vendors like VMware, which is providing this hypervisor solutions, like Red Hat their own, and then so many are there, right? VMware is one which is very popular, easy to use, and which is very much a stable company now acquired by Broadcom. Anyway, so now you can see that if you have hypervisor, in my case, I have type 2 hypervisor. For example, I have one hypervisor which I am running over my Windows operating system. So I have VMware workstation, and in that VMware workstation, this is one of the example of type 2 hypervisor, because this hypervisor I have over my, you can see my, oops, it's gone. You can see my hypervisor. So what I have done here, behind you can see my hypervisor. What I have done here, that I have EI labs, GNS3, some Palo Alto firewall, the other labs and all. So within one operating system, I have these applications that I am running, right? Even in this, I can go and install Windows, Ubuntu, Mac OS, etc., etc. And on top of that, I can run the different applications, right? I'm using some hypervisor technique to optimize my hardware performance. So this is one example, this is one example. That's okay, no problem. Then why we are using containers? Containers has different use case. I told you about the segregation of application, that maybe you have one application, you are in the development team, and you have one application that is belonging to Python. That application you have developed for Python flavor 3.10. But the business ask is this, that you have to test that for 3.9. You have to test that with 3.2, and then you have to test with a legacy Python version that is 2.9. So the coding for Python 2 is very much different coding with Python 3. They have changed so many things in 2 versus 3 and all those things. This is just one example, but there may be so many dependency. And if I have such type of ask, then this model will not serve that purpose. So in that case, what you can do, and that's commonly used by different type of container companies like Kubernetes and others, that they are doing some sort of packaging. So you have your operating system, and on top of that operating system, you can go and package the application, and that is known as a container, one container, two, etc., etc. So I have my operating system, and on top of operating system, I have container, suppose container one, which is running Python version 3.10, and then I have container 2, which is running 3.9. Likewise, I have container 4 and 5, container, for example, 5, which is running Python 2.x, right? So different instance of packages, you can pack it and run it over operating system, and on top of that you can go and develop different flavors of applications. So you can do some sort of this is termed as a operating system virtualization. This is termed as a server virtualization. This is normal. So this virtual machine concept is server virtualization, and this container concept is nothing but the operating system OS virtualization, because now you have one OS, but you have the container concept on top of that operating system. Obviously, you have container operating system. Likewise, you have hypervisor. So you have some sort of Docker or some operating system which is doing this. On top of your operating system, you have some container application. On top of that container application, you can go and build different containers. Right? You are able to understand these concepts?
Yes.
Right, so let's see here. VM, as we discussed, virtual machines. What I have done, I have one diagram here. So you have physical hardware where you have CPU, memory, storage network, and then you can use hypervisors. For example, ESXi. ESXi is one of the hypervisor from VMware. On top of that, you can run different instance of VM. On those VMs, you can go and install guest operating systems, and on top of that, you can develop the application. Right? Very easy, straightforward for VMware. For bare metal, how this bare metal look like? These bare metals, you have physical hardware, CPU, memory, storage, and all. You can install one OS and you can install the application and it will work. You can see this diagram versus this diagram. Here you have multiple operating systems, and here on the resource you have only one operating system, right? Then let's see the container. Now you will see the container. You have the physical resources like CPU, memory, storage, network, OS. Then you have some container application like Docker application, and then you have container 1, container 2, container 3. What this container contains? These are application libraries binaries, application libraries binaries, application library binary, right? This container runtime is actually very fast. It will run like this, you know. Now, if you see the boot time, for example, boot time for this operating system will be high. Boot time for these are less, because then I have other options in VMware that I can take snapshot. I can go here, right, and click start. It will take maybe 10-15 seconds and my OS is ready. Now I can go to this OS and I can start my applications and all. It's very fast. Like VMware is fast, but even the containers can work within nanoseconds, like, you know, just to start the application. So developing applications over container will be maybe uh, 30 time or 40 time faster than VMware, because anyways VMware, they are not native to the applications. So once you have guest operating system, then you have to install the libraries, binaries, and all those things. And you can't develop multiple instances of application in one OS. Like if you go and install Python 10, then Python 10 is there. You don't have virtualization here. But if you have multiple applications with different version, like same application, version 1, version 2, version 3, then it is not possible, but it's like you need to use this and that and this and that, which is very much easy in this. Package everything within one container and it will work, right? So that's why you will see that virtual machine, bare metal, and containers. In virtual machine, I just wanted to focus on boot time. Longer, bare metal faster than VM, because you can argue on this because you have so many OSs and all. Your load on the machine is more, so that's the reason. But container, they are very fast. Portability, they are very portable, right? They are moderate. Scalability, easy to scale. They are highly scalable. For application development, container is obviously the first choice. And that's why you can see the demand for all these Kubernetes engineers and someone knows programming and container concepts and all.
Yes, you
R-
mentioned Kubernetes. What does it mean? Is it
Those are,
like like another doc, something like that?
yeah, they are also container management system. So now what you have done, that for example, you develop so many applications, right? So yeah, for example, you have so many different container, like you have 10 or 15 container. Then you need some container orchestrator, right? To manage these containers and resources. So that Kubernetes is nothing but container orchestrator. You can manage different containers with Kubernetes, right? For example, Cisco DNA. What is Cisco DNA? You can manage different type of routers, physical routers and switches, but you need some sort of orchestrator from where you can allocate the resources, manage the things. So that's why we have the Kubernetes. I can have one container or two container, no problem. I can manage it individually. But if you have 100 containers, which containers uh, we are using what resources and what applications and how I can manage the containers. That is nothing but managing different container system. That's Kubernetes. And there are others as well, right? If you have any question, please feel free to ask. Thanks for joining today, day number 13. This is very interesting session today. We are going to learn a little bit of lab as well. And here you can see the agenda for today's session, starting from 4.4, 5, and 6. I will try to cover these three topics today. 4.4, understanding the components of CI/CD pipeline. This is very important concept while doing the software development, their management, and how to collaborate and develop a certain piece of software or complete package, CI/CD pipeline. Then construct a Python unit test. What does it mean? I'll explain you. And then we have to work on Docker file. You can see the agenda is interpret contents of a Docker file. So today we are not going to perform the lab related to Docker file. That maybe tomorrow we'll perform the lab. So here you can see 4.7, we have to utilize a Docker image in local developer environment. We'll see that. Let's focus on these three topics, these three agenda. Let's check this. So let me go to that particular slide where we have 4.5, 4.4 CI/CD pipeline. Maybe that will start with slide number, yeah, slide number 188. Describe the components of CI/CD pipeline. This is very much related to application development deployments. Let me show you the chart first, then I'll come back. So here you will see the chart, the graph, that CI/CD pipeline diagram having some steps. Step number one, that source control management. Source control management, actually this is there to manage your source code, plus if any collaboration is there, different engineers can give their code, right? Like they can update the code from their side, their package, their part, and then they can put some feedback. Say this is version 1 and now we are updating to 1.1. So 1.0, now I'm updating to 1.2, etc. So overall cycle, you can see this with the CI/CD pipeline, that you have to do source control management, then continuous integration, that is CI, and then you will see CD. CD here, your D stands for either deployment or delivery. So continuous integration, continuous delivery, or continuous deployment, or uh, yeah, continuous. C stand for continuous and D stand for either deployment or delivery. So continuous delivery, deployment, right? Now in this circle that we have, this chart that we have, this is not, very new type of chart or something. This is very much that how we should do the application development and deployment, right? So suppose if you have to develop application, what you need source code, right? So you have your code, you have your program. Now this program will be integrated, or this program is something that will have some evolution, means it will evolve. Later on you will go and add some more packages. So today suppose this is one of the transport app, for example, Uber app. So today if they are providing services for four-wheeler, tomorrow maybe they will add two-wheelers as well, or in India we have three-wheelers as well, right? So that means they can go and add something. So you have some framework and you are going to add something, that is nothing but your continuous integration. You will integrate something into that, and then artifact repository means obviously the feedback and all those things you will add. Then once your code is integrating, so 1 2 3 and then you can see 4, this is like something like this. So once you are integrating the code, you want to run this as well, right? So you can go and provide continuous delivery, and your deployment, you want to do some automation for deployments. So phase number 1, phase number 2, phase number 3, phase number 4, phase number 5, this is something that CI/CD pipeline. But whatever your deployment is there, whatever feedbacks you have, you want to monitor and log it, right? You want to monitor your deployments, and then you want to add some security features in that, and then you want to take the feedback. So you have some applications that you are running, that is providing some services, but you need some customer feedback as well. You need some feedback. Feedback is nothing but documentations. So you need proper documentation, that further, if you add something, remove something, what is the reaction, all those things will be here in the feedback. Because if anything, any service do not have feedback, the service will not get improved. Even for networking related tasks also, we are getting some sort of survey, like customers. So once we close the ticket, that survey is going to customers, and then they are giving some rating from 1 to 10, or 1 to, in between 1 to 5. 5 is best and 1 is worse. If it is not good, then there is option to put some comment as well, that why this service is not good and all. And likewise, we are doing continuous improvement, right? So once you have the feedback, in any form, then you can go and improve the services. So you can see this CI/CD pipeline that is inbuilt in the Git and other repository or other services that we have for collaboration and version controlling, that is there. But the cycle that you can see here is not very new. This type of cycle we are using in our normal service operations as well. So for example, you have some task you want to complete, then you will add certain things in that task. Then you have some artifacts repository, then continuous delivery, you want to automate your deployments, you want to monitor it, you will obviously go and add security features in that, and once it will get completed, you should have the feedback, or this is nothing but the documentation, maybe some feedback, maybe some improvement, and some errors, some bugs, etc., etc. Everything will be captured here in this document, and then the improvement. Let me go ahead to back. I have 3 4 points here. You can see the source control management, Git, GitHub, GitLab, Bitbucket, where you have the source code. What is the function? They can manage the code, the repository, track the changes, collaborate with the other engineers, like they can push the request and all. So you can do the source code management. Then continuous integration. There are servers like Jenkins, Travis CI, Circle CI, Git Lab CI. This is one of the popular tool we have that is there doing the continuous integration. But some of the tools here is CLI based, some of the tools here is the GUI based. Function, you can see function automatically builds and tests the application whenever code changes are pushed to the repository component. Basically this is for testing purpose, something like doing the test. So here you can see the automated tested, like unit test. What is this unit test? That is 4.5. In section 4.5 you'll know about the unit test. Integration test to verify code changes. So these are the tools, CLI or GUI based tools, that can go and perform the testing related to the functions or the packages that we are developing. Then artifact, you can go and store the uh, code. So you can see the function is store built artifacts. We have something like Amazon S3, Nexus, JFrog artifacts, where we can go and store the artifacts, store the binaries, package, Docker image for deployment. When we are running our Python program, we are importing some package like import JSON, import request, import this thing. So those packages that we are importing, that is stored somewhere, right? Because we are importing from somewhere, although that is local to my system, but you can refer to some repository as well for different packages. You will learn this thing in the Docker. In Docker section, we have Docker section where we are going to pull the Docker images for different things. And you know what is Docker? Docker is nothing but your operating system virtualization. You can virtualize your operating system. That means your operating system can run multiple applications at a time, because you are creating containers on top of your operating system, and that container is nothing but packaged with different types of libraries, binaries, codes, images, all those things, right? So that is the artifact. Then continuous delivery and continuous deployment. Both are CD, right? So CI/CD, continuous integration, and then continuous delivery and deployment. So delivery, what we want to do, there are tools with that we can go and deliver that. You can see that is Spinnaker, Octopus Deploy, AWS Code Deploy, Google Cloud Deploy, etc. What's the function? Automates the deployment of application to different environments such as development, staging, and production. We have development, then pre-production environment, and then the production environment of production. Within the production, you are checking the codes. So develop it, check-in, the staging, this is the pre-production, and then the production. What are the components? Environment management, continuous configuration management. Manage different deployment environments, ensure consistent application configuration across the environment. Now, these things that you are seeing here, like all those points that we have related to CI/CD pipeline, I can go to my Git, right, repository. There you will see all these options. So within one repository itself, or you can say that source control management tool itself, you have all these options. Jenkins is something that you can integrate for CI. Repository you can call from some repository, and we will see that example in the Docker. Then continuous delivery is there for to manage different deployments and ensure consistent application configuration across the environment. Then continuous deployment. You want to deploy, do the automation for deployment. So fully automate the process of deploying to production. This is one of the tasks that most of the enterprises they are looking for, right? This is very interesting topic that you have something. So for example, I have my code and I have deployed to the production. Then how this code will get kicked? So there may be, or there should be some triggers that if something will happen, the code will start running. If that is the case, that if some, for example, CPU percent is more than 80%, then this code will trigger. That is nothing but your automation, right? Means with help of automated conditions. So your script is something which is sensing that if something is, if I'm getting some trap or some event is happening, then I'm running my script. That is nothing but automate the process for deployment. And there are multiple ways to achieve it. One way to achieve is this, that you can go and integrate your Python with EEM script, right? Embedded event manager script. And once you go and embed your Python with EEM, and in that you will go and put some message that if CPU is high, if I am getting alert on my console or in my log, then this Python script will get triggered. Or if some interfaces are down, run this Python script. Like that, you can go and create the script, right? So that is something related to auto deployment. Then canary release rolling updates gradually deploy changes to subsets of users. So see, whatever thing you will do, either we will go and create your source code, right? In this also you have the collaboration, means nothing is fixed. Like you have your code, but it needs some versioning, it needs some collaboration, right? If you are doing your deployment, suppose if I am doing my deployment, then I can improve my deployment as well. As per the feedback, I can go and change my source code. And if I change my source code, my method of deployment will get changed, or I can add something for auto deployment. I can remove something from auto deployment. So point number 1 to 5, whenever we have this process, then we can monitor and log. So what are the examples for monitoring and log? And at the moment, most of the organization, if they are monitoring and logging, I can say 90% of the organization at the moment, they are using Prometheus, Grafana, Elk. Elk is nothing but E for Elasticsearch, L for Logstash, K for Kibana. Now all three functions, all three term that you are seeing here, they have three different use, right? Search, logging, and monitoring. We will see that. I think I have one slide for this. And you know that customers, they are using a Splunk as well. If they are not using a Splunk, they will use this. A Splunk is, I think, is costly, and this is not that expensive. This Elk Stat, Elasticsearch, Logstash, Kibana, and You know where we are using in our network this, even if you're not using it externally, internally also you have these things in your SDN framework. You know, if you go and see Cisco DNA tools, within Cisco DNA we have this ELK stack. Elasticsearch, Logstash, Kibana is already there in our DNA operating system. Then a Splunk, that means you can export anything to a Splunk, and a Splunk can monitor it, and even it can take some action as well, like it can go and give you some feedback as per the input, right? Then monitoring application performance, collect the log, provide alert for issues, etc. Then we have application performing monitoring, APM tools, monitor application health and performance. Log aggregator, you can go and use ELK stack. It will provide you the log aggregation, troubleshooting, analysis. These tools are actually very important, these two tools. Even people are using Grafana and Prometheus as well. Okay, before I move further, if you have any question, please ask.
One question, Ranesh, is this software development is good for like, well, I think it is good for large projects,
Yes.
but for small projects, it is recommended to use like this type of tool.
I have seen enterprises, like big enterprises also, they are using these tools.
But for a
They,
small,
for small also,
for
they are
small,
using these tools.
okay, so it's good for both
Both,
projects.
yes, yeah, both. They are actually good. I know these tools from beginning, like when they have started their concept of elk stack, and then how they have grown. Now they are big company. Earlier, they are not that big, and they are selling their product for free for 90 days or 6 months and all those things. Now they are very much stable, and people are using their product.
Grafana is free, no?
Grafana is free, yes. Most of them they are free only. You will get it. And if you use Docker container, then the packages are there with the Docker containers. It will auto deploy in your Docker. It will create the container and you can run the application. Okay, so whenever you are using these softwares, like for free, then you can't raise ticket with them. Like if you want support and services, then they will charge you for support and services, right? All right,
Okay.
let's move and let's check the remaining points. So feedback loop, this is actually very important, and this should be there in normal operations as well. So feedback loop function provides feedback to developer and operations about the status of build, test, and deployments. Components, notification dashboard, email, Slack, other messaging services to notify about the build state, test result, and deployment outcomes. Dashboard, visual representation to track the status and health of CI/CD pipeline. Like you have the GUI dashboard from where you can check the status. You have the notification in terms of email and paging and Slack, etc. Whatever the outcome we have for the deployment, right? Then you can see that security. Yes, security is one of very important topic we have. And section number 5 is complete security. I think in this section also, the upcoming topics we have, that is where we are going to discuss about OWASP. What is the security product, right? It's a big product, this OWASP, and what are the security features they are providing. We'll discuss it. We'll discuss this tomorrow more about this. At the moment, security tools are there. Snake, white source, sonar cube, OWASP, this we are going to discuss. Function, integrate security practices into CI/CD pipeline to identify and remediate the vulnerabilities early in the development process. So we need security packages as well, because if it is vulnerable, then it will not scale. Okay, few examples I have added. This is actually very big topic, the CI/CD pipeline. And if you see the requirement for the companies nowadays, I can see that different companies, they are looking for the automation engineers who has working knowledge of this CI/CD pipeline, how this CI/CD is working, and they will mention simply that knowledge of CI/CD. But within that CI/CD, there are so many things that need to be understood. Okay, within Git itself, they are providing this CI/CD pipeline. So you can see the components. We have the static application security testing, dynamic application security. Some examples are there related to this DevOps. And then you can see this chart. You can go and have a look on this particular chart where you have all these 8 components of CI/CD pipeline. This is continuous integration, continuous development process. This is not just a term. This is entire software development process, right? Where you have everything from managing the source code, developing it, doing integration, storing somewhere, delivering it, making that delivery automated, monitoring, logging, providing securities, getting feedbacks, and do the improvements, right? So have a look on that. Next topic we have, this is related to lab. This is very interesting. I will give you the history as well about this. Now, suppose if you purchase one Cisco switch, for example, Catalyst 3850, what is your expectation with that switch? You got my question?
Oh, sorry,
Oh,
I didn't get it. Can you repeat that?
Yeah, so suppose if I am purchasing Cisco 3850 switch, right?
Yes.
Cisco 3850 switch, why I am purchasing? What is my expectation with that switch?
just interconnect devices in the network.
Connecting the devices in the network, yeah?
Yes.
Okay.
And
Uh,
provide
uh,
some kind of security in the network.
Services, security, and all this, right? So my follow-up question is this, that how many devices you can connect to that switch?
Usually the numbers of ports on
Number
the
of
switch,
ports. For example, if it is 48 ports, then
48 devices.
48
Usually.
devices.
Mhm.
Okay, we can connect. All right. So suppose if I have to create 50,000 VLANs, is it possible?
1,000 VLANs. Then the memory will be crashed.
Crash, right? Suppose if my expectation is that it will go and hold 1
Maybe
billion
10,
of routing.
20.
So
Oh,
routing table limit is there. A number of VLANs limits are there. Their CAM table are there. So whenever we are purchasing any hardware, we are checking their limit as well, right? Like for example, data center leaf and spine switches. So we are checking that what will be the QoS performance, how much uh, traffic how much IPv4, IPv6 routes it can learn and store, right? How many MAC addresses it can learn and store, right? What will be the overall throughput, like 1 Tbps or 2 Tbps when I go and connect these switches in their full performance mode, like it is connected, all the interfaces are connected. For example, my leaf, they are connected with all these spines, means whatever number of connective uplinks that we can go and connect. So after connecting it and my network is fully populated, there is no remaining port that I can go and connect, and it's like a very big data center in terms of that very heavily utilized data center. And in that data center I am running most of the services. And then you know and then as per the guarantee from the vendor is telling, oh, my switch will support 1.2 Tbps, right? They are telling it my switch can learn these many MAC addresses. When we are, as a customer, when we are purchasing the switch, can we test it? We are testing it. No, right? We are not doing that test. So whatever that vendor, they are selling to us, that telling that this is this is it, and you can use it and it will support this. We are not testing from our side, right?
Usually no.
Okay. So my point here is this, that how Cisco, like any vendor, they are testing their hardware.
I'm guessing they create his own scripts or
Scripts,
to
right?
validate the memory. So,
Some scripts, some automations, right? That is nothing but they have one department that is doing protocol testing. So you may have seen that requirement for protocol testers. And even Cisco is not doing those testing. They are giving these to some third party, small companies, like, okay, this is my switch and this is my limit in this switch. Can you go and generate traffic? So there are tools that can go and generate the traffic, MAC addresses and all, right? And can you go and test it that this much IPv4 addresses it can learn and hold this feature? For example, they have some feature related to IPv6 security. For that, obviously they need some network, like they can't put that switch in some production and enable those features and test it. They will test in lab only, right? There is no other option. So that means there is one big framework where they are testing. They are sending all these, what you can say, that fabricated traffic, not the real traffic. They are not doing the testing over real traffic because it is not possible until unless it is there in production. How someone can go and test in the real traffic? So there are tools like Xia for traffic generation, and there are so many other tools as well that they are doing this testing. So they are writing a script, right? So I'll give you one more example. For example, OSPF. Let's check very easy example. OSPF. OSPF is a routing protocol which has multiple features, which has features related to OSPF area. You can create multiple areas. Where it has features that you can go and create the authentication, like in between different OSPF neighbors. Over the link, we can go and enable the authentication feature. We can go and put some timers, right? Like features are there with protocol. Now these features, so I am developing one protocol called OSPF, right? And I have to go and check the authentication is working or not. If I go and enable authentication, is it working or not? Or if I go and enable the network type point to point, this feature is working or not. I have to test somewhere, right? And that is task of protocol testers. They are testing these protocols, that this is the protocol and its behavior is correct or not, right? But for them also, they can't go and test all the protocol feature in a single shot. So in that case, what they are doing, they are writing the test case. test cases. They are termed as a testlet. And when I was working as a protocol tester, so we are getting some test bed. So my company, they are assigning test bed to us. They are telling us these are the 4 tests you have to run and provide the result today. This is nothing but part of the protocol, that part of the feature that you want to test. If you have to test some feature, some small portion of the protocol, right, then you need some sort of unit testing. That you have a big protocol OSPF, but in that big protocol, you want to test only one feature, right? How you will test? So for that, you can generate the unit test, construct a unit test. And this is just very small example in this we have uh, in our curriculum, but this is a big topic related to protocol testing. So we can go and use unit test module, which is part of Python standard library. Unit test module we can go and create. For example, I have one function, add function. This function I want to test. Say this is one of the function of mathematics operation. In maths, we have different operations like addition, subtraction, multiplication, exponential, etc. So many, like thousands of functions are there in math operation. But in this math operation, I want to check that if I go add a plus b, then it is giving the number which is correct or not, right? So suppose if a is 2 and b is 2, then if I go and test it, so it should give me 4, right? So this a and b, I can go and use different options. I'll tell you about the option. So for example, this a and b, okay, you can take 2 and 2. Obviously, it will give 4. If I run the test and it will not give 4, that means test fail. If it will get 4, that means test is passed, right? Now, why only 2 and 2? Can I take minus 2 and 2 and it should give 0, right? Why only minus 2, minus 2? I can go to minus 2 and minus 2. It will give me minus 4, right? Can I go and test 0 and 0? It will give 0. Can I go and test minus 10? Oops, sorry. Minus 10 and 5. It should give minus 5. Now you can see that different scenarios we have. You have one function, right? You have one function, but you can see that we have different scenario. 2 positive numbers, 1 positive, 1 negative, 2 negative numbers, 2 zeros, right? 1 bigger negative, 1 smaller positive, like that, you know. These are nothing but what? The scenarios. Scenarios that you have to test it. These are the options that you want to test it, right? Any doubt understanding this concept? So likewise, the protocol testing is happening. In protocol testing, you have multiple options. On those options, you have to generate multiple options and scenarios. So see, these vendor companies, the Cisco and other companies, right? These vendor companies, they don't know customer scenarios. So someone can purchase 3850 switch and they can use it, that switch, just as a L2 switch. And someone can go and purchase that switch and they can use that switch as a L3 switch. Someone can go and use as a L2 plus L3. Someone can put that switch in ISP environment, like, you know, it is working as a router and it is connected with the ISP routers. Someone can go and connect that switch to the below the leaf switch where it is connected with some servers, right? So different use cases are there. So you have same unit, I have same number, like same function, right? But it may have different use cases. How I can test it? That is nothing but doing within the unit test, right? So then we have unit test module. We can create a test file. That's a test bed we are creating. Import the modules and create the test cases and all. So we have this module here, and I can go. So here you can see that I will go and import the unit test function within Python. I am calling this math operation. So this program that I have, operation, within that I am calling this add function. So I'm calling that add function, right? Now I have one class defined, math test operation, unit test dot test case. So unit test dot test case. What I want to check? I want to check positive numbers. I want to add the positive numbers. So 2 plus 1 plus 2 will give me 3. So this will be pass. Add negative numbers. -1 -2 will give me -3. This will get pass. I will show you fail condition as well in this. And then add positive and negative, 0. Now the assertion 0 0 0 5 5 0, etc., etc. This is the testing that we are doing. What we are testing, this add function, from where it is coming, from this math operation, right? Let me show you this in live. I have this example there. Pull here. I'm going to show you this example. First of all, you can see the math operation. That's the function we have, right? This math operation function, we want to test it. This, let me run this, and you will see. I will change the output as well. Say test math operation.py. You can see what it is telling. That some errors are there. We'll see that ran 4 tests in this second, failed 2 failures. In this, we have 2 failures. You can see my example, 1 plus 2 will never become 6. So you can see here the output, 3 is not equal to 6. So this is failed. Then -1 -2 -3. So this is okay. This will pass. This test will pass. Then -1 1 -2 will not become 0. But if I go and put here -2, and if I put here, for example, 4, if I run this test, now it is showing that only one failure. -2 -2 will not become 0, right? If I put 4 here, ran 4 test in this second and okay. So which is working fine here. You're able to understand this. This is just a small, very small piece of a big concept, protocol testing, where different phases are there, right? To test a function or feature of a function, we can test like this. Okay. Any question you have?
If you put a letter instead of a number, it will show
Let
you
me
as failure or an error on the
Okay, I'll put some letter for example. A. Name A is not defined.
Okay, so it's a fail.
Failed with errors. Okay, all right. Let's move to next session. That is very interesting, and we have very interesting lab related to that section. That is related to interpret contents of Docker file. For this Docker and container, we have lab as well. So tomorrow we are going to perform the lab related to this. We know about the concept of Docker, right? Last time we have discussed about this. This is OS virtualization. So you have one operating system, only one operating system, but you can create containers on top of that. So different containers having different application and packages, but who is providing you capabilities to do that? There is one other operating system that you are running, or not operating system, other program that you are running. That program is nothing but the Docker related program. Docker is nothing but one sort of program, right? Which will allow you to create your containers, container 1, container 2, up to container n, right? So now this Docker, there are Docker file, right? So you can go install Docker in your Windows, and if you want to make yourself ready for next class related to Docker, then you can go and have a look on section number 4.7. I have given the link, or you can use these commands, and you can make sure that you have Docker in your system, in your Windows, Mac OS, everywhere. These are the free tools we have. You can go and install it. I have my Docker for Windows in my system. Let me open and let me show you how it look like. But you can use this command. This is for Linux, Ubuntu. For Windows, simply you can get one exe file and you can install it. It's very easy. But I'll explain you this in next session. This is a pre-work. If you are interested, you can have Docker install in your system and you can execute the program. I'll share tomorrow. You can take it, run it. You can see the result. Let me show you this Docker desktop I have. Simply you can go and install the Docker like this, and you can see containers, images, volume, builds, like that. We have the options here. This is very much like GUI, right? But in Linux system, you have very much CLI based Docker. You can run it, see the results and all those things. Anyways, let me go back to this topic, that is interpret contents of a Docker file. Docker file is a script containing series of instruction of how to build a Docker image. Each instruction creates a layer in the image, and the resulting images can be run as a container. This is something that we need to understand. So Docker is a file that you can build the images, the layer of images, and that will provide you container, right? So I don't have ACI here, but let me show you this. GitHub ACI Docker. There is one very famous Docker we have for Cisco ACI, and if I can open that, I can show you that. Let me open the GitHub link and share my screen. Search ACI Docker. Where it is? Library ACI convert or ACI, Cisco ACI, Cisco ACI. If I go here and if I filter, okay, NetOps, Docker, go back. Let me go to this repository, Cisco DevNet. Let me see if we have the Docker here or not. Docker image, my ACI, my ACI app. Then it will run. You will understand this. I'll explain you this. I'm checking some easy format, easy Docker that simply I can go and install in my Docker and I can show you that. So let me search like this, not from here. That is ACI toolkit, Docker, or just ACI toolkit. I think this is Cisco Epic. Basic toolkit access Cisco Epic. Cisco Epic is older. ACI toolkit. Empty. Empty seems these are the empty. Cisco ACI toolkit. Why they are creating empty repositories? I don't know. ACI toolkit. Okay, you can see this, right? Let me show you this. Let me open my CLI. Oops. And so we can do say git clone. Oh, it's clone command is already there. Oh my god. Let me paste git clone, right? So I'm copying this. Now I can go to where? I can go to CD ACI toolkit. That is my repository I just now downloaded. Right. And then we can, because in my laptop, I have Docker installed. So I can run Docker related command, Docker pull, Docker Cisco ACI toolkit. So now on top of my Docker that I have, right? I have Docker already. This I have shown you. So in this, you will see that they will go and pull that file, right? And you can see the images and containers and all those things once it will get completed. Although I can see via CLI as well. So it is pulling that. It's a very big file. You can see 200 MBs and all. Pulling this toolkit, ACI toolkit, and installing in my Docker. I can see via CLI or my GUI also. Show me that. So now, got installed here. What happened? Completed. I can see the image. You can see this toolkit. See here, this toolkit, right? It is installed here. Now I can go and run this. I can click here run, it will run. So once it is installed, then what it is telling that, you can use this these commands to install it, right? I can run it, no problem. Now I can use this command. This is CLI command, paste it. Now I am in the ACI toolkit. You can see I am within the container shell. Now I'm not in my Windows shell, I'm in my container shell. I can go and see the files here. So if I can go and see the files, there is one file called scripts. And let me go back, CD samples. See, all these ACI related Python programs are there. So someone has created the package, and this is not the Docker file. Simply what we have done, we have installed in our laptop. All these functions are there. So if my laptop is connected with ACI, I can go and see the uh, the output here. So I don't know which Python it is running. Python 2.7. Okay. You can see that in my laptop I'm running 3.10. In this package we have this Python 2.7.12 and all the build functions and all. So if I have to run this any of the programs, so for example ACI and show and tenant and py. Oops. What options we have? Tenants. So tenants dot py. So now it is asking the username, password, and all. If I have ACI connected with my laptop, means if I have reachability, it will execute that program and it will give me the result. And in case you are looking for the program, how it is, so you can go and see this, right? Show tenants.py. This is the program. Copyright Cisco system, and then what it will do, how it is running, and all those things. But this is in little bit older format. This is Python 2.7, but I can run 2.7, 3.7, 2.9, anything, because this is part of one package, one container. So this is the output. To get this output, if you want to build your own file and packages, so you need some sort of Docker file. So if you go here, and if I have some Docker file here, I can show you that. Docker, you can see this Docker file. So if I go here and show you this, this is the build. This is the example related to Docker file. So in this version 1.0 from this Python, within the Docker, we have different Python. Maintainer, he's the maintainer for this. Running, what it is doing. So Docker file is nothing but different type of commands clubbed together. So if I go and run this Docker file, I will do apt-get update, install, git, graphics package, config package, Python package, all these packages. And then I will move to this folder cd/opt. Then I will clone this package, right? Git clone GitHub. Then I will go to the toolkit. Then toolkit will go and install the Python setup.install and then clean that unwanted things. And then this is my working directory. What is my working directory? opt/ACI toolkit, and then run the bin bash. Once you are in this, you are in the bash shell. This is something that the instructions in Linux, which is in single file, that is nothing but our Docker file. So if you see the Docker file here I have added the comments like from this Linux 3.9 Slim, set the variables like Python, bytecode, and unit buffer, etc. This is the work directory. Copy the requirements to the app, then pip install the requirements, then copy the app and then run it. This is even simpler example compared to this. So if you are here also you can go and see the Docker file. Let me open the Docker file here. See, this is how small this is. It's a very small program, and you can run this program and your Docker is ready. This is your Docker file. You can run this and you will get some result. See how easy and fast this is to run and execute, because Dockers are like that only. Once you are able to build your container, then they will work fast and then they will provide you the faster result. Okay. Any doubt? You can feel free to ask.
Yes.
Yeah.
Is any risk to download this to your laptop? Any virus or something like that?
No virus. They are
No
clean.
virus. You sure?
Sure, 100% sure.
Okay.
I'm using it from last 3-4 years. This tools. It's no problem at all. Even I have used in the production environment as well. They are safe and maintained.
By Cisco.
Yeah, with Docker means they are charging for it. Like for basic services, it is free. But if you want to have some advanced services, they will charge. You know, one interesting thing, most of the important things are free only because people don't know, so they are paying.
Mm.
Let me pause the recording.